Welcome to aminacademy.com. In electrical engineering, let us discuss about cylindrical capacitors. Cylindrical capacitor, that is the capacitor is used to store large amount of electric current in a small space. The cylindrical capacitor includes a halo or a solid cylindrical conductor surrounded by the concentric halo spherical cylinders. Capacitors are widely used in electric motors, floor mills, electric juicers, and other electrical instruments. The potential difference between each capacitor varies. There are many electrical circuits where capacitors are to be grouped accordingly to get the desired capacitance. There are two common modes, including capacitors in series and capacitors in parallel, that we'll discuss later videos. Now the unit of capacitance is farad F. Look at these figures. Here a cylindrical capacitor. A single core cable or cylindrical capacitors consisting two coaxial cylinders of radius A and B meters shown in figure. Let the charge per meter length of the cable on the outer capacitor of the inner cylinder to be positive coulombs and on the inner surface of the outer cylinder be minus q coulombs. For all practical purposes, the charge positive q coulombs per meter on the surface of the inner cylinder can be supposed to be located along its axis. The epsilon r be the relative permittivity of the medium between the two cylinders. The outer cylinder is earth. Now, area of curved surface we know that equal 2 pi x into 1 meter height, which is equal 2 pi x meter square. Means from x distances. Now, the value of electric flux density is flux in coulomb over area in meter square. Now, that is, we can write psi over A, which is equal, we can write Q over A, then coulombs per meter square, and D is Q over 2 pi x, that is flux in coulomb over area 2 pi x. Now, electric intensity is E equal d over epsilon 0 epsilon r, or you can say E equal Q over 2 pi epsilon 0 epsilon r x into, that is volt per meter. Now, dV, change in volt, dV equal minus E dx, or E equal or V equal here, not E, that is integral dv equal minus integral e dx. Integral dv equal to v and integral b to a minus e dx, which is equal b to a minus q dx over 2 pi epsilon 0 epsilon r x. Now for the simplification we'll get v equal minus q over 2 pi epsilon 0 epsilon r is constant taken out from the integral b to a, a to b or b to here b a to b, here dx by x, here which is equal integrating 1 over x is minus q over 2 pi epsilon 0 epsilon r is 1 by x is log x b to a, which is equal v equal minus q over 2 pi epsilon 0 epsilon r log giving values of a and b, which gives b by a, log b by a. Now q by v is a capacitance, that is here 2 pi epsilon 0 epsilon r over log e base b by a. Therefore we can say the capacitance is, we can write 2 pi epsilon 0 epsilon r over 2.3, because we are converting log e base to log 10, that is 2.3 log of base 10 b by a farad. This is a capacitance of the cylindrical capacitor. So in case of capacitors has compound dielectric or compound dielectric mediums, for C is 2 pi epsilon 0 L over sigma log E b by a or epsilon r. The capacitance, for suppose for example capacitance of 1 kilometer length of cable in microfarad can be found by putting L equal to 1 kilometer in a bow. We can get it, the value of capacitance. Any values of length of the conductor, we can find the capacitance. Now next, potential gradient. Potential gradient in a cylindrical capacitor. Here we'll find cylindrical potential gradient in a cylindrical capacitors. We know that E equal Q over 2 pi epsilon 0 epsilon r x volt per meter. where x is the distance from the cylinder axis to the point under consideration. Suppose some points on the cylinder. Now E equal G means potential gradient. Therefore, you can say G equal Q over 2 pi epsilon 0 epsilon r x volt per meter. This is a potential gradient. Now substituting the Q values, we'll get G equal 2 pi epsilon 0 epsilon r V over log E B by A 2 pi epsilon 0 epsilon r x. Then cutting the common terms, we'll get G equal V over x log E B by A. In terms of therefore, in terms of instead of log E, you can write 2.3 log 10 also you can do. This is a formula for potential gradient, that is V by x into log E base over log E B by A. Now let us do an example problem. A cylindrical capacitor having a length 8 cm is made of two concentric rings with an inner radius 3 cm and an outer radius 6 cm. Find the capacitance of the capacitor. Look at this. Given thing is length is 8 cm, inner radius is 3 cm, outer radius is 6 cm. The formula for cylindrical capacitor is C equal 2 pi epsilon 0 L over len B by A. Len means log E. Now we are using the values to pi value. Epsilon 0 is 8 into 8.5, 8.85 into 10 raised to minus 12 into length is 10. 8 centimeter is converted to meter. 8 into 10 power minus 2 len B by A. Len B by A is 6 centimeter, 3 centimeter, both are converted to meter and cut. It gives same 6 by 3. So gives C equal, final answer, 1.477 into 10 raised to minus 11 farad. We have done. Please subscribe our YouTube channel.